Hello viewers, my name is Chandan Kumar. I am working as an assistant professor in the School of Advanced Computing in Sage University, Bhopal. In previous lectures, we have discussed a lot of concepts regarding database management system. In this video, we are going to learn about the different inference rules that are used in functional dependency. These are my contents of this video. First, we will talk about functional dependency and the different rules of functional dependency. And at the last of video, we are going to learn about trivial functional dependency. At first, we are going to discuss about what is functional dependency. A functional dependency is nothing, it is just an association among two and more than two attributes in a table. Suppose in a table we have two attributes, one is called x and another is called y. If somehow y attribute is dependent on x, so it is represented as x tends to y. Here x is called determinant and y is called the dependent. Because y is dependent on x, and we can say in another language that x determines y. That's why x is called determinant and y is called the dependent. In this example, you are watching that here we have four attributes: sin, name, address, and birthday. And in this example, here x is represented by sin and y is represented by combination of three attributes that is called name, address, and birthday. And the arrow is between sin to name, address, and birthday. So we can say that sin determines name, address, and birthday. So in this example, sin is called determinant, and the other three attributes, name, address, birthday, are called the dependent attributes. Here we have some inference rules that are basically used for function dependency. It is also called Armstrong inference rule. Armstrong was a scientist which has discovered which has who has identified these rules. In these rules, at first we have reflexive rule. What is reflexive rule? If x stands to y and y is the subset of x, then this property is called reflexive property. In this example, you can see that here roll number and name, both the attributes determines name attribute. So in this example, y is carrying only name variable and x is carrying roll number and name. And you can see that name is the subset of roll number and name. So we can say that this holds the reflexive property. Second is called augmentation. Augmentation is nothing, just we have to add a common attribute in both the sides of functional dependency. Suppose x tends to y, and now we are going to choose an attribute that is called z. So we have to add z attributes in both the determinant and dependent attributes, and that's how it shows like xz tends to yz. As for example, suppose we have a functional dependency in which combination of roll number and name determines department building. Suppose we have chosen a variable attribute that is called department name. So we are going to add department name in both the dependent and determinant attributes. So this is called augmentation property. Next rule is called transitive. Transitive is nothing, it is just like if x determines y and y determines z. So basically, it can be said that x determines z. As for example, suppose roll number defines department name and department name determines department building. So we can conclude that roll number determines department building. So these three property, that was reflexive, augmentation, and transitive. Combination of these three attributes were called Armstrong inference rules. Apart from these rules, we have also some different inference rule that is called decomposition. In decomposition, if x determines the combination of y and z, that means x determines y, z, so we can decompose this functional dependency into two different functional dependency, that is called x tends to y and x tends to z. And same as we can learn about union. Union is nothing, just reverse of decomposition, that is called if x tends to y and x tends to z. So we are going to combine both the rules, that is x tends to y and x tends to z, and it becomes x tends to yz. It is also visible that the decomposition and union both are the alternative, both are the opposite of each other. And next one is pseudo transitivity. In this rule, if x determines y and wy determines z, then we can say that wx determines z. This pseudo transitivity rule can be proved by the Armstrong axioms, that is reflexive, transitive, and augmentation. Now, we are going to learn about trivial functional dependency. It totally depends on reflexive property. In reflexive property, we have learned about if x tends to y and y is the subset of x, then it's called the reflexive property. So if any functional dependency that contains, that follows the property of reflexive, we can say that that particular functional dependency is called trivial, otherwise it is called non-trivial. In simple language, if any functional dependency follows reflexive property, then it is called trivial functional dependency. And if it does not follow reflexive properties, then it is called non-trivial functional dependency. As for example, in this table, we have three attributes: roll number, name, and age. Here, we can see that roll number and name, combination of roll number and name determines the name attribute. So in this case, name is already a subset of the combination of roll number and name. So it follows the reflexive property. So we can say that this particular functional dependency is called trivial functional dependency. It is also visible by the slide that if roll number determines only roll number, it also follows the reflexive property, because if x determines x, that means x is the subset of x. So it holds the reflexive property and it's called trivial functional dependency. And if it does not hold reflexive property, so it will be called non-trivial functional dependency. So in this video, we have learned about the basic of functional dependency, Armstrong inference rules of functional dependency. And apart from Armstrong, we have also learned some different inference rules, as well as we have learned about trivial functional dependency. Thank you for watching this video. Thank you.